In this video, we're going to be going over buck boost auto transformers. Now, an auto transformer is a transformer that shares a common winding. Now, the difference between this type of auto transformer and a typical auto transformer is in this one, we're using a standard dual winding transformer. You might notice here, I've got my H winding, my high side on this side, and I've got my X winding down here. So this isn't a standard auto transformer. This is a standard dual winding transformer. The difference is we've taken a jumper and connected a jumper from H1 to X1, and then we've connected a load from X2 to H2. So in effect, we've turned a dual winding transformer into an auto transformer because now they do share an electrical connection, and that's how we define a auto transformer. So let's take a look at how these things work. As with any transformer, the first step you want to take is to determine the rating of your windings. We need to take this guy here. This is the rating of the transformer itself. It's a 600 to 120 volt, 15 kVA transformer. That means my high side is rated at 600 volts and my low side is rated at 120 volts. The 15 kVA we're going to use to determine what the current is through each winding. We go 15 kVA divided by 600 to get the high side current, and 15 kVA divided by 120 to get the low side current. So there we go. I've gone 15,000 divided by 600 to get 25 amps rated on the high side, 15,000 divided by 120 volts to get 125 amps rated on the low side. Again, the next step is within any transformer, and if you go back and watch the video on ratings of transformer, you'll notice that we discuss polarity. So we need to pick a polarity here. We need to determine what this polarity is and what this polarity is. I'm just going to pick randomly as this negative and this positive. It would work the other way too if I pick this as positive and this is negative. But for this example, we're going to go with negative, positive. Now I've determined the polarities here, negative, positive, which tells me that if this line is negative and this line is positive, H1 is going to be negative, H2 is going to be positive. Now we learned too from our video on ratings of transformers that whatever the polarity is of H1 is going to be the polarity of X1. So if H1 is negative, then X1 has to be negative. If H2 is positive, then X2 is positive. So now we have our polarity set up. We have our ratings in here. What's going to happen here is we're going to kind of follow along and see what happens. We've got a positive 600 volts going and hitting to a negative 120 volts. At this point, I like to use the battery method. I treat this like it's a battery from positive to negative, and I treat this like it's a battery from negative to positive. Let's take a look at what that looks like. So in this case, I have 600 volts, positive to negative, and it comes into contact with a negative to positive 120 volts. So I'd be taking 600 volts and subtracting 120 volts. And that would give me the voltage that I would have at my load, which ends up being 480 volts. Now we've determined what the voltage is at the load. This is the maximum voltage that this load will see, or can safely see with the configuration we have. The next step is to figure out what's the maximum current that we can have here. Well, all you have to do to get that is to figure out which of these two windings is in series with this resistor. And looking at it, you can see that this winding here, the low voltage, is in series with the load. So therefore, if this winding can see 125 amps, then this load could see 125 amps. So that determines the maximum current that this load will see. Same as this one, 125 amps. Now we have a voltage and we have a current. We can determine the maximum kVA that this load can safely ask for with this configuration. 480 volts times 125 amps is 60 kVA. So we're almost done this connection here. We've got a 60 kVA load here. Now the next step would be to determine what my line current is. And my line current is up on this line and going back on this line here. It's not the winding currents. Now we can look at this and say, okay, I have 60 kVA as the load is asking for, and knowing what we know about transformers, whatever the transformer has to give, it's giving out on this side too. Your primary has to equal your secondary. Power in is equal to power out. So if I have 60 kVA at the load, I have to have 60 kVA at the source. Now I've determined the power being asked for over here, 60 kVA. I have a voltage of 600 volts. 60 kVA, or 60,000 divided by 600 volts, gives me my line current of 100 amps. And this is what we like to call a buck connection. We say it's bucking because this voltage bucks against, it pushes against that voltage to give us this voltage here. In reality, what's happening is this flux is pushing against that flux to give us this voltage. But I'll discuss that more in a later video. Now in this next example, we've got the same transformer here, it looks like, but you might notice a little difference. I've got H1, H2, and before I had X1, now I've got X2, X1. So let's see how this all plays out. Again, all of our ratings have stayed the same, basically the same transformer except for the way we've got this connected here. And we'll play out and see how this works. All right, we've determined what the polarity was up here, negative, positive, which determined our primary, negative, positive. If H1 is negative, then X1 must be negative. See, there's the big difference from this one to the last one. H1 is negative there, X1 is negative there, H2 is positive there, X2 is positive there. So if we hop in the car and go for a drive here, we're going positive to negative 600 volts, positive to negative 120 volts. So it's like having two batteries in series with each other. 600 volts, positive to negative, plus 120 volts, positive to negative, gives me 720 volts at the load. Okay, now I've got 720 volts at the load. We need to determine the maximum current that could safely be delivered to this. Again, we look for the winding that's in series with the load, and we see that we have 125 amps here that is in series with this 720 volts that is being put across this resistor here. 125 amps is what we're going to put on this guy right here. All right, now that we've got our voltage and our current, we can determine the maximum kVA. All we have to do, just like before, 720 volts times 125 amps gives me 90 kVA. Now again, with the whole principle of transformers, power in is equal to power out. If this guy's asking for 90 kVA, the line side has to give 90 kVA. Now I have 90 kVA up here. We can use this to determine what the line current is up to this point here. 90,000 divided by 600 volts gives me 150 amps. Now one thing you notice, or you might have noticed, is this is a boost connection, which means that this flux here is boosting this flux here to give me an overall voltage of, say, 720. So the voltage ends up adding together. You notice that our line current is actually, because it's a boost connection, 25 amps plus 125 amps gives us 150 amps there. That's a good way to double check it. And the same thing works for when we have a buck connection. If this was a buck connection, just as an example, say this was hooked up buck. I know it's not, just ignore all that. But if this was buck, I would take 25 amps minus 125 amps to get the high 100 amps that we had before. So that's just a great way to double check your work. As that is, though, the way that this is all connected here is a boost connection. So there you go. The mystery of the buck connection and the boost connection auto transformer is solved. They're not that difficult, but as with any transformer, you have to figure out what your ratings are and get them drawn in. Then you have to figure out what your polarity is. Your line polarity determines your primary polarity. Your primary polarity determines your secondary polarity. And then we have to follow along here and see which way we go, because that jumper has caused these two guys to be in somewhat of a series circuit. And that is the buck boost auto transformer connection.